All right, so I've given you a few minutes to finish the warm-up. If you're watching the video, pause it and do the warm-up first. This is just what we did yesterday, so hopefully it was pretty easy to recall. All right, so Amy, tell me, what is the arc sine of 1/2? Pi 6. Yes, ma'am. Thank you. All right, arctangent of square root of 3 over 3. Anaya, what's that? Pi 6. Yes, ma'am. Thank you. Arc cosine of negative 1/2. Marco? Negative pi thirds. Do you all agree with that? Why not? 0 to pi. It's cosine, right? So cosine, we can only use the first and second quadrants. So give me what's your second quadrant pi thirds angle? 2 pi thirds. Very good. Okay, so does that make sense? Remember how on cosine we can only use quadrants 1 and 2? Okay, good. So you got the pi thirds part right. All right, good deal. All right, arc sine of negative square root of 3 over 2. Kayleen? Pi thirds? This is a negative square root of 3 over 2. So it would have to be what? Negative pi thirds. Very good. Okay. Arctangent of negative square root of 3. Madeline? Okay. So what angle gives me a tangent value of the square root of 3? Pi thirds. Okay, so since this is a negative square root of 3, what would my answer be? Good. Negative pi thirds. So your brain's working just fine. All right. Arc cosine of negative square root of 3 over 2. Sit, Lolly. I'm sorry, what? Pi 6. This is a negative square root of 3 over 2. And it's cosine. You're on the right track. Sorry, what? But since it's cosine, I have to go from 0 to pi. So I need the second quadrant pi 6 angle. 5 pi 6. Very good. Okay, any questions about those? Those cosines can trip you up, right? We good? Okay, because we got to be able to do this to do what we're doing today, because today we're doing compositions of these. So this says to recall what we know about inverses. So it says recall, given a function f and its inverse, f inverse of f inverse. If x is in the domain of both functions, then f of f inverse of x equals x, and f inverse of f of x equals x. So, and this says if x is in the domain of both functions. So this doesn't just straight up work 100% with all functions, unless, I mean, if our domains were all real numbers for both of them, then we'd be fine. But remember, we have to restrict our domain. So since we are restricting our domain, then it's not always going to work just exactly like this. Yesterday, we wrote down, remember that the sine of 7 pi 6 equals negative 1/2. Sine inverse of negative 1/2 doesn't equal 7 pi 6. It doesn't always go frontwards and backwards. So when we write it as a composition, it's going to look kind of like this one here. We'd say that the f inverse of, I'm sorry, I'm writing f. It is the f inverse and the what, but I want to actually use the sine. So the sine inverse of the sine of 7 pi 6. So if we didn't have a restricted domain, then the sine inverse of the sine of 7 pi 6 would just give me 7 pi 6. But we know that it does not equal 7 pi 6. Okay, so we have to pay attention to some intervals here. We're going to look at those. All right, so we'll start with the ones that kind of go after this. So it says, if blank, then sine inverse of the sine of x equals x. So it doesn't here, but it would if the x fell between negative pi halves and pi halves, because those are the two quadrants that we get to use for sine. Okay? So if that was pi 6 instead of 7 pi 6, then that would just be our answer. Which quadrants do we get to use for cosine? 1 and 2. So since I'm using 1 and 2, that means it's going to be between 0 and pi. And then tangent, what quadrants do we use for tangent? 1 and 4, good. But it doesn't look exactly like this because we have asymptotes, so we don't get to include the pi halves. It's just, there's no equals to on there. Okay. Now, those are based on our domain restrictions. Our range didn't get restricted. So if I want to take the sine of the sine inverse of x, so remember what you're taking the sine and the sine inverse of. You always take the sine, cosine, or tangent of an angle, and it gives you a trig value. If you have a trig value and you want the angle, that's when you take the inverse, right? So you have to know, like, what does this x represent? This x would represent a trig value, not an angle, because I'm never going to take the sine inverse of an angle. So this would be the sine inverse of a trig value would give me an angle. Then I'm going to take the sine of that angle and get some sort of trig value there. That'll just straight up equal x as long as x is between -1 and 1. And same goes for cosine. Has to be between -1 and 1. Because that's your range of a sine or a cosine function. Think about a tangent function, not the inverse, just the regular old tangent function. What's your range of that? -infinity to infinity. Good. Oops. -infinity to infinity. Okay. And I'll show you how we're going to use those right here. So it says to find the exact value of each expression if it exists. Maybe it doesn't exist. So the sine inverse of -1/3. So I know that the -1/3 has to be a trig value because I'm trying to take the inverse of it. It's not a trig value that we've used though, right? I don't know what the sine inverse of -1/3 is. I don't expect you to know. But maybe we don't need to know because the sine of the sine inverse of -1/3 will just be -1/3 as long as -1/3 fits between -1 and 1. Does it fit between -1 and 1? Yes, it does. So my answer is just -1/3. You don't have to know what the angle would be. So cosine of pi fourths. Pi fourths represents an angle, not just because it has a pi in it, but because I'm taking the cosine of it, it would have to be an angle value. And we know what the cosine of pi fourths is, but we wouldn't necessarily need to know. The arc cosine of the cosine of pi fourths will just be pi fourths as long as this angle fits between 0 and pi. Does that fit between 0 and pi? Yes, it does. So my answer is pi fourths. Or, if I didn't know my intervals, the cosine of pi fourths is square root of 2 over 2. And then the arc cosine of the square root of 2 over 2 is pi fourths. Okay, you can get it right back if you have to actually do the work in between. All right, so let's look at this one. The arctangent of the tangent of negative pi halves. Does negative pi halves fit in this interval? No, it does not, because they're not included, right? So I don't know what the answer is yet, but I do know that it's not negative pi halves. So in order for me to figure out what it is, I have to evaluate what's in here. So I'm going to take the arctangent of, and whatever this is what's going in those parentheses there. What is the tangent of negative pi halves? Undefined. So I'm going to take the arctangent of undefined. Well, I can't take the arctangent of something that isn't even defined, so I can't, there's not an answer. This one does not exist. Then I have the tangent of the tangent inverse of -9/2. That, again, is a value that we're not familiar with. So my answer will be -9/2 as long as this fits in the range of tangent. Does that fit in the interval of the range for tangent? Yeah, because what is it? It's -infinity to infinity, right? So we're good. It's -9/2. Okay? Questions about that? All right. So let's look at number 5. The arcsine of the sine of 3 pi fourths. Does 3 pi fourths fit between negative pi halves and pi halves? What quadrant is 3 pi fourths in? The second. And I only get to use the first and the fourth. So it doesn't fit. So we don't know what the answer is yet, but I do know that it's not 3 pi fourths. Okay? So I'm going to take the arcsine of whatever the sine of 3 pi fourths is. What is the sine of 3 pi fourths? Square root of 2 over 2. And then what is the arcsine of the square root of 2 over 2? Pi fourths. Good. So the answer is not 3 pi fourths. It's still a pi fourths angle, but I have to use the first quadrant version of that. Okay. We okay with that? Maybe? All right. The cosine of the cosine inverse of 2/5. So 2/5 is another one of those values that we're not familiar with. Okay, but I can take the cosine inverse of it as long as it fits between negative 1 and 1. Does that fit between negative 1 and 1? 2/5? Yes, it does. So my answer is just 2/5. So the arcsine of the sine of 5 pi thirds. Does 5 pi thirds fit in the interval? And since this is an angle, it's the angle interval, which is negative pi halves to pi halves, and 5 thirds does not fit there, right? So the answer is not 5 pi thirds. So I have to work from the inside out. The arcsine of, what is the sine of 5 pi thirds? What quadrant is that in? 5 pi thirds, fourths. So it's going to be negative, right? And then pi thirds, negative square root of 3 over 2. All right, so then the arcsine of negative square root of 3 over 2 is going to be negative pi thirds. Okay. Questions on how we got that? All right. Cosine inverse of the cosine of negative 4 pi thirds. Well, my answer is not negative 4 pi thirds because that clearly doesn't fit between 0 and pi, right? So that means I want the cosine inverse of, all right, negative 4 pi thirds is in which quadrant? Pay attention to the negative. Second. Because if I start over here and I go, that's going to be 3 pi thirds, 4 pi thirds puts me in the second quadrant. In the second quadrant, is cosine positive or negative? Negative. All right, so cosine, the cosine of negative 4 pi thirds is going to be negative, what? 1/2. All right. So then the cosine inverse of negative 1/2, it's a negative value, so it has to come from the second quadrant. I was in the second quadrant, I just went backwards to get there, right? So it's a pi thirds angle. What's your second quadrant pi thirds angle? Your second quadrant pi thirds angle? 2 pi thirds, yeah. Okay. Questions about that? Mm-hmm. With negative 4 pi thirds? Is that what you're asking? We start here, we go this way. That's 3 pi thirds, that's 4 pi thirds. Because it's negative. Positive 4 pi thirds would put me in the third quadrant. Am I wrong? All right, so this is 3 pi thirds. Oh yeah, so this is 1, 2, 3, 4. You're not being dumb. It's okay. But 3 pi thirds is like pi, right? That's the way I do it. I go, okay, if I'm here, that's 3 pi thirds, then I have to go one more. Okay? That's easier than like counting them individually. Does that help? Okay. All right, so let's look at number 9. the tangent of the tangent inverse of pi thirds. Pi thirds looks like an angle, but do I take the inverse of an angle? No, just because it has a pi in it doesn't mean it's an angle. That pi thirds is a trig value. It doesn't look like the trig values we usually see, but it is. So I have no idea what the tangent inverse of pi thirds is, and that's okay. I'm fine as long as that pi thirds fits in the interval of the range of tangent. Does it? Because that's negative infinity to infinity, right? So since this fits in negative infinity to infinity, the tangent of the tangent inverse of pi thirds is just pi thirds. I don't have to figure out what the angle is, because this is not an angle. On number 10, the arc cosine of the cosine of 3/2. Is 3/2 a trig value or an angle? An angle, because you take the sine, cosine, or tangent of an angle, right? It doesn't look like the angles that we normally see, and it's not a typo that's just missing a pi, all right? So I don't know what the cosine of 3/2 is. Don't expect you to. But arc cosine of 3/2 will be fine as long as this angle fits between 0 and pi. Okay, so between 0 and pi, what is your decimal approximation of pi? 3.14. As long as you know it's a little bit more than 3, that's all you really need to know here, right? So when I get here, that's a little bit more than 3. Is 3/2 between 0 and a little more than 3? It sure is, because it's like 1.5. So my answer here then is just 3/2. Okay, any questions? All right. Arctangent of the... Yeah, is your question? Oh, I'm sorry. You guys speak up with my old lady ears. I'm not sure. I don't know what you're speaking of. No, it's okay. I just don't know what you're asking me, that's all. Okay, if it comes to you, let me know. Okay. So we have the arctangent of the tangent of pi. All right. Does pi fit between negative pi halves and pi halves? It doesn't, does it? Even if it did, you could still work it from the inside out if it's a value you can do. So arctangent of, what is the tangent of pi? 0. The tangent of pi is 0. And then the arctangent of 0, what angle gives me a tangent value of 0 that's in the interval I want? 0. Because the tangent is 0 at 0 and pi. Pi just doesn't fit in that interval that I need. Okay, so it's just 0. Alrighty, the sine inverse of the sine of 11 pi sixths. Well, that clearly doesn't fit between negative pi halves and pi halves, so I'm going to work from the inside out. And what is the sine inverse of negative 11 pi sixths? So we can start by thinking, what quadrant is negative 11 pi sixths in? Negative. It's in the first. It's in the first because it's negative. All right, so then basically I just need the sine inverse of pi sixths. I'm sorry, not the sine inverse, the sine of pi sixths. Sorry, I said that wrong. Just 1/2. And then the sine inverse of 1/2 is pi sixths. What questions you got? All righty. So this whole front was about when they match, the arctangent of tangent, the sine inverse of sine. If they don't match, then those intervals don't matter. And that's what these look like here. Okay? We've got, says find the exact value of each expression. If it exists, work from the inside out. Okay? So we're doing basically the same thing. We just don't have to worry about the intervals here. And they'll pretty much, on most of these, have to give me values that we know. So I want the cosine inverse of the sine of pi 6. So the cosine inverse of, then this value goes in here. What is the sine of pi 6? 1/2. And then the cosine inverse of 1/2 is what? thirds. Okay, we okay with that? All right, so then the arctangent of the cosine of 0. So I want the arctangent of, and then cosine of 0 goes in here. What's the cosine of 0? 1. Good. And then the arctangent of 1 is pi fourths. Okay. Well, good so far? All right. Sine inverse of the tangent of negative pi fourths. Sine inverse of, what's the tangent of negative pi fourths? Negative 1. Good. And then the sine inverse of negative 1 is? Okay. So, and that's good. I've heard that every period. 3 pi halves should be the first thing that pops in your mind because that is where we get that negative 1 from, right? But I can't answer it as 3 pi halves because my answer has to be between negative pi halves and pi halves. So it's fine to think the way you've been thinking around the circle. 3 pi halves should be what comes into your head first, or you at least picture that. But then I have to go this way, so my answer is actually what? Negative pi halves. Because those are coterminal angles, it gets us to the same spot, but my answer has to be between negative pi halves and pi halves. Okay? Because there's actually an infinite amount of angles that would give me a negative 1 value, but that's why we restrict the domain. We have to restrict our answers. Okay. Arcsine of the cosine of 5 pi 6. So that means it's going to give me the arcsine of, what is the cosine of 5 pi 6? Negative square root of 3 over 2. Good. And then the arcsine of negative square root of 3 over 2 is going to be negative pi thirds. Negative pi thirds. Good. All right. Any questions at this point? All right. So I'm going to give you about a minute. I want you to do 17 and 18. Oh, and on 18 it says arctangent inverse. That doesn't make any sense, so mark out the little inverse there. All right. Homero, tell me what? Wait, did I not give you enough time? Okay. What is the tangent of pi fourths? 1. And then what's the cosine inverse of 1? What? 0. 0. You can say it loud and proud. 0. You're right. Okay. 0. All right. We good on that? Okay. Michelle, I know you were absent yesterday, but let's test you here. All right. What is the sine of negative pi halves? Well, you should know that much at least. Sine of negative pi halves. That would put us here. What's that sine value? Negative 1. Good. So then the arctangent of negative 1, that means what angle would give me a tangent value of negative 1? Or tell me what, I'm going to lead you through it differently since you weren't here. It's pi fourths, and then since it's negative, it has to come from the fourth quadrant, but we don't use our fourth quadrant angles. We have to go the negative way. So it's negative pi fourths. You got it. Good job. All right. Any questions about those two? All right, then y'all do 19 and 20. Cameron, what's the sine inverse of 1/2? Pi sixths. And then the cosine of pi sixths is square root of 3 over 2. Very good, thank you. All right, Liz, what is the arctangent of 1? Pi fourths, good. And then the sine of pi fourths is? Square root of 2 over 2. Good job. Any questions on either one of those? All right, then do 21 and 22. Alrighty. Jeremiah, what is the arc cosine of 0? Pi halves, good. And then the sine of pi halves is? Good job. Okay, we good on that? Alrighty. Then, Jenny, what is the tangent inverse of the square root of 3? Pi thirds. Because there's only 1 3 in there, right? So then what is the cosine of pi thirds? 1/2. Good job. All right. Any questions about those? All right. So when we had matching ones, like this is tangent of cosine inverse. If this was cosine of the cosine inverse of a value that we didn't know, then we could use those intervals we had. But when they don't match, the intervals don't matter at all. Instead, we're going to have to draw a picture here. So this says to let the inside be theta. So when I take the cosine inverse of that value, whatever it is, it's going to give me some angle. I don't know what it is, but it's an angle, and I'm going to call it theta. So then I'm going to look for the tangent of theta. That's what I'm trying to figure out. Tangent of theta. All right? So whatever theta, I don't even care what theta is. So I'm going to draw myself a picture. I know that if I take the cosine inverse, I can only get angles in the first and second quadrant. This is a positive cosine value, therefore I'm going to be in the first quadrant. That's how I know where to draw my triangle. Here's my triangle. Okay? Cosine is adjacent over hypotenuse, or x over r, and so that means that this is 8 and this is 17. Tangent is y over x, or opposite over adjacent, and I don't know what y is, so I got to figure out y. How can I figure out y? Pythagorean theorem. Yeah. So I get 8 squared plus y squared equals 17 squared. So when you do that, I know you can do Pythagorean theorem. You're going to get y is 15. Plus it's a Pythagorean triple, so you might just know it. Doesn't really matter. But now that I know that the y value for that angle is 15, whatever the angle may be, I can now find the tangent of that angle by doing opposite over adjacent, or y over x, and that is 15 over 8. Okay. What questions do you have? What's your question? You're looking at me like I'm crazy. Where did I lose you? Where did I get 15 over 8? Because I'm doing the tangent of the angle. The tangent is y over x, or opposite over adjacent. Good? All right. So now I'm going to look at this one. I have the sine of the arctangent of negative 12 over 5. So this, again, this again gives me some theta, whatever it may be. Once I figure out what my triangle looks like, I don't really care what theta is, then I'll just be able to find the sine of theta. All right. So tangent, when I take the arctangent, I'm going to get triangles either in the angles in the first or the fourth quadrant. This has a negative tangent value, which means it is in the fourth quadrant. That's how I know where to draw my triangle. And then I know that tangent is y over x, or opposite over adjacent, and one of the two is going to be negative, and since I'm in the fourth quadrant, I know that the y value is negative and the x value is positive, so this would be a negative 12 here and a positive 5 here. And then I'm going to need the radius. So once again, I'm going to do Pythagorean theorem. It's going to be 5 squared plus negative 12 squared equals r squared. And then once you do your thing, r equals 13. That's another Pythagorean triple, but if you don't know them, that's fine. You can do Pythagorean theorem. You should be able to do that in your sleep. So then when I take the sine is opposite over hypotenuse, or it is y over r. So that's going to be negative 12 over 13. What questions do you have? Okay, so your assignment is informative again. I'm not a big fan of giving you 30 problems of the same thing. If you can do it, show me that you know it in a couple. But sometimes in math, things require drill and practice. And when they do, it should go pretty quickly. So the first part of the assignment that's in there today is a review of yesterday. The second part is what we actually did today. So it's going to look like a lot, but if you know what you're doing, you'll be able to fly through it. The other thing is the way that this was put in, the question, I guess there's a different keyboard for this. It's a different instructions than what I gave you yesterday. When you click on the keyboard, you will get something that shows up on the bottom, but I think it's different than the one that you've had on the bottom before. But the pi will pop up there, and you should be able to use it without issues. Okay? If you have any issues, let me know.